example C. Oh, by the way, in your notes, 3 root 3 over 2 r squared, that's equation 1. Okay, example C, let's use the same system as before. So to remind ourselves, we had 98 megahertz, 20 kilohertz per call, reuse factor 7, and cell size 0.5 kilometers squared. So now let's shrink cells to 0.25 kilometers squared. How many calls in the city? So we can go back and solve this with first principles, but we can also notice that half the area, double the calls. So I can't remember, I didn't actually write it down here. What number did I have before? 39,200. Multiply that by 2, and we get 78,400. Okay.
Just double the number of cells.
Basically, you just doubled the number of cells.
In terms of overall cost of building stuff.
Right, exactly. So basically, if your total base station cost was X dollars, to do this, you spent 2X dollars. Example D. Let's do what I just said and use the same system with the cell size back to 0.5 kilometers squared. So now let's use reuse factor 4. So, first, let's calculate how many clusters in the city. Actually, I just did it over there. We have 28 kilometer square city. Each cluster, the area of a cluster is 4 times the area of a cell, which is 2 kilometers squared. So we have 28 divided by 2, which is 14 clusters. How many calls can I make in a cluster? Basically, it's 98 megahertz divided by 20 kilohertz, which is 4,900. So the number of calls I can make is 4,900 times 14, which is 68,600. That sounds about right. Yeah, you're right. 68,600. Equivalently, I could have multiplied, I I think you'll find that if you multiply the original answer by 7 over 4, you would get that. Okay, so that's your basic introduction to the concepts of cellular telephony, the design trade-offs involved in basically partitioning space into cells and dropping base stations in the middle of each cell. In other words, the important things to think about are how big is each cell, how often are you reusing your frequencies, how many callers do you need to support, and things of that nature.